We're going to be taking a look at our next lesson in this video, and let me just find my spot so we can get going. So we've been working on Unit 2, Chapter 7, where we're looking at quadratic functions, and in this unit, we're looking at solving quadratic equations using the quadratic formula. So the objective of the lesson was to make sure that you understood, first of all, what the quadratic formula was, when we use it, and then how to navigate your way through safely to find the roots of a quadratic equation. The vocabulary that will pop up as we talk about this would be imaginary numbers and roots. So as you know, we've been exploring how to find the x-intercepts of a quadratic function. We've used graphing, we've used the factored form, we've used factoring. But the question is, what happens when we cannot factor at this point? Algebraically, what happens? So our next choice is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you will remember that we used the melody to Pop Goes the Weasel in class to kind of learn this and be able to sing our way through it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that melody can kind of help you as you move towards trying to memorize this guy. A couple of other hints. Always check first to see if you can factor. Factoring is much easier, so make sure that you do check and rule out that option. So we have this first example. I'm going to go now to a screen where I've done the solution, and let's walk our way through it. The first hint that I give you in this one is when you're getting ready to substitute the numbers in, put the numbers in a bracket, and that will keep the negatives safe. So you'll notice when you look at what I've done with this one first, that I first move over the 8x and get it safely in place so that I know what a, b, and c actually are. Once I have a, b, and c, I'm going to put them in brackets. So I put in a b of 8, 8 squared, minus 4 times 2 times negative 3, all over 2 times 2. Next, I'm just going to try to clean up my work a little bit. 8 squared is 64. I have two negatives, so that will turn into a positive. And I have 4 times 2 times 3, which is 24. Next step, I put these guys together, so it's 88. Now, at this point, let me go back one. At this point, I need to simplify the radical. Now, I know that this radical is 4 times 22. 4 is a perfect square, and when I pull it outside, it becomes a 2. That leaves me with a 2 outside and a 22 inside. Okay, now at this stage, you still have to simplify this expression, and the safest way to do that is to pull it apart into two fractions. Negative 8 over 4 plus or minus 2 root 22 over 4. And then we simply simplify. We get a negative 2 for the negative 8 divided by 4, and we reduce this guy to 1 over 2. This should be a 2. I'm just noticing that that's an error in what I've written, so please do make sure that you realize that that should be a 2. I'm reducing this 2 over 4 to 1 over 2. So some of the hints for that, remember you have to simplify the radical, and remember as well to break your answer into two fractions and then simplify. Okay, the next example is a classic example of when the quadratic formula would be useful. This one is a formula, or this is an equation anyway, when the numbers are very messy. And being able to do anything with it is really awkward. So we use our quadratic formula. We take our numbers, first put them in standard order so you know which is which. Plop in the 0.82 for the b. You have 4 times negative 2.75. This should be a 15.3. I think when I took the scan of it, the 0.3 knocked off. And then we have 2 times a down on the bottom. Now in this one, we're going to be using a calculator. And some of the tricks that we used for that would be, remember that when you're setting up a graphing calculator, if you use alpha y equals, and if you choose number 1, which is n over d, it gives you the chance to create a fraction. Then, once you've typed everything in, let's say for the plus version of this one, when it's time to figure out what it is with a minus sign, use your cursor to go back up to it, highlight what you had printed in, and press enter. And then you have the opportunity to use it once again, and you simply have to replace the sign right here in the middle. Those are two sort of tricks that we use for using your calculator. Make sure you only use the calculator at the end and watch out for those things. These are the calculator tips once again. Here's where you're doing alpha y equals. This is not the screen that you will see. Unfortunately, I couldn't find anything online with that, but choose number 1, which says n/d. And once you've entered the equation for the first intercept, simply use your cursor to copy it and then adjust the plus or minus sign depending on which one you did first. Okay, the next one looks like a fairly simple, unassuming one. And so we're going to plop in our B, our A, and our C, and so on. Now, when we get down to this one, when we actually calculate our numbers, we have 9 minus 20, which gives us negative 11. And that gave us the opportunity to talk about what happens when there's a negative under a square root sign. We talked about how mathematicians created something called the imaginary number, which is the square root of negative 1. And so we can simply rewrite our answer as 3 plus or minus the square root of 11, I divided by 2. So a negative root is an imaginary number. And this comes from what we had talked about as well in class. Now, we're not going to go far with imaginary numbers, but they are a whole branch of mathematics that's very interesting, very exciting with what we do. Okay, and one thing about this particular quadratic equation that is worthy of note is to take a look that when you graph this one, it looks like this. And what's significant about this is that the graph does not have any x-intercepts. So it turns out that whenever you have an imaginary root like this, that you have a function which does not actually cross the x-axis. So we say it has no x-intercepts. Okay, the following example is a question which we're going to be using a little bit later when we start to do some of our problems. And so I'm just going to stop at this point and give you your assignment. Now, your assignment for this one, let's go through to it just for a minute if we can. We actually simplified it. So we only gave you question number 4 in that first assignment. These other questions I'm going to pick up later when we're working on section 7-8. So a few changes that you need to make, but hopefully this video will give you a good idea of where to go with the work that we did for 7.7. Okay, good luck with your homework, everyone.